You're welcome once again to New Focused Approach to Mathematics Basic 8. This is the revised edition. In this video, we want to learn how to construct a locus of a point equidistant from two intersecting lines or two fixed lines. Now we are looking at the third condition, two straight lines. So two intersecting straight lines. I have a line here, for example, like this, and that one intersect this way. Now, could there be a line or a path that a point can trace to have equal distance from these two lines? Let me call it line AB and then line AC. And that line can be like this. It can pass through the middle here. If I pick a point here, from this to this, from this to this will be the same. A point here, from this to this, from this to this will be the same. And it will continue in that direction. Even if I pick it outside here, from the point here to this line to that line will be the same. That is what we are trying to learn here. Let's take example and see. Let's say you are given these particular dimensions to construct. Let's say line MN 8 centimeters, NR 7 centimeters, and MNR 60 degrees. Want to construct a locus L3 such a way that it will be equal distance from MN and NR. So it's more or less you are drawing a triangle. So let's get a triangle done. Let's say the triangle can be drawn this way, and assuming that the label comes as M, N, R. Then the line MN is this one, NR is that one. That means we have this angle to bisect. When we bisect this angle, we'll get a straight line that will be a locus L3, which will be equal distance from these two lines. So that is what we want to look at. Let's construct it and see. All right, so first of all, let's draw the line MN, which is 8 centimeters, right? So 8 centimeters. So I'm going to label M and N. And according to the question, our NR is 7 centimeters. So I'll use my compass, pick the measurement of 7 centimeters. Okay, 7 centimeters. Yeah, so that's our 7 centimeters, right? Then I'll put a compass pin at N and draw an arc. Okay, so that is our arc. Then the question said again that we should draw an angle MNR to be 60 degrees, MNR. So on the same end, you're going to get an angle of 60 degrees. So I'll put a compass pin here. With a convenient radius, draw a semicircle. With the same radius, I'll put a compass pin here. As usual, you know how to do this already. Okay, so that I'll make my first mark, which is the 60 degrees. Sorry, yeah, 60 degrees. So I'm going to now join the point N through the intersection to meet the first arc. So now I can draw passing through this, passing through that. So that becomes our line MN. Sorry, our line MN R. So then we have our R here too. We can now join R to M to complete our triangle. Right. So we've gotten our triangle M N R. Now the question wants us to construct a locus of a point which is equal distance from MN and NR. So it's more or less you are going to bisect the angle MNR. So with the help of our compass, we put a compass pin here. Then we open to a convenient radius and construct an arc. With the same radius, put the compass pin here. Okay, and then you are going to construct another arc to bisect the first one, so intersect the first one. Now with the help of our ruler, we can join them together. So I can join this and maybe extend it a little bit. Because the locus, it can go on and on and on. Right, so this is our L3. L3. So this is how we construct locus of a point equidistant from two fixed lines. So you can see that any point I pick on this line, even if I pick it here, from here to here will be the same as from here to here. If I pick it from here to here will be the same as from here to here. If I pick it outside here, from here to here will be the same as from here to here. So that is what we call the locus of a point equidistant from two fixed points, or sorry, two fixed lines. Thanks so much for watching.